Hello Stings. In this video we are going to be looking at the laws of exponents. First we will look at the law of exponents vocabulary. This whole thing is what we call a power. You have a base raised to an exponent. That situation is called a power. An exponent tells us how many times a number, the base, is used as a factor. So a power has two parts. It has a base and it has an exponent. Now we have some laws that govern how we add, subtract, multiply, divide these. So exponents that are 0 or 1. So let's first look at an exponent of 0. Anything raised to the 0 power is 1. Here, what's being raised to the 0 power is actually the x, not the 4. The 4 is being raised to the first power. So this becomes 4 times 1 because x to the 0 is 1. So we end up with 5 times 4, which is 20. In our third example, we have 2 times x to the 0 over y squared. X to the 0 is just 1, so 2 times 1 is 2. And our denominator stays y squared. Our next example has a product being raised to a power. In this case, both the 3 and the x are being raised to the 0 power, so that answer is 1. And no matter how complicated something might look, if you raise that whole complication to the 0 power, your answer is simply 1. Now we go for an exponent of 1. An exponent of 1 is something we don't usually write down. So x raised to the first power is simply x. A number raised to the first power is simply that number. So in this case, 10 to the first power is 10. Our next law we're going to look at is the law of negative exponents. So anytime you have a negative exponent that says either put it from the numerator to the denominator or from the denominator to the numerator, you need to change the location of where the power is. So x to a negative a means 1 over x to the positive a. So in this case, 3 is our base, our exponent is negative 2, so that says take that 3, put it in the denominator, and make the exponent positive. 5 times x to the negative 3. Remember, this 5 has an invisible exponent of 1, so that 5 is just going to stay a 5. It's going to stay right where it is because that 1 is positive. But this negative 3 exponent on this x says put this x in the denominator with a positive 3 exponent. Now, if the negative is in the exponent, you have a negative exponent in the denominator, then you're going to go from the denominator to the numerator and make that negative a positive. For this example here, we have 12 to the first power times x to the first power times y to the negative 2 all over w to the third power z to the negative 1. 12 to the first power is just 12, and because 1 is positive, it stays in the numerator. X to the first power, that 1 is positive, it stays in the numerator. But this negative 2 says take the y squared and put him in the denominator. Now we've taken care of the numerator, we look at the denominator. W to the third power, since the 3 is positive, the w to the third power stays in the denominator. Z to the negative 1 says I'm in the wrong place. Put me up into the numerator with a positive 1 as my exponent. Our next law will be the multiplication law of exponents. Basically, if the bases are the same and you're multiplying them, then you can just add their exponents. So here the bases are x, so we can add their exponents. So 2 to the second power times 2 to the third is 2 to the 3 plus 2, which is 2 to the fifth power. X to the fourth times x to the third times x is going to be x to the 4 plus 3 plus 1, because even though this does not have an exponent written there, it does have an exponent of 1. We just don't normally write it down. So simplifying this, we end up with x to the 8th power. In our next example, we have coefficients as well as exponents. The coefficients just get multiplied just like normal. So 4 times 2 times 5 gives me 40. Then our x's have like bases, and we are going to add their exponents. So this is going to give us 40 times x to the 5th power, because 3 plus 2 is 5. The division law of exponents is very similar, except instead of adding, we're going to subtract. So I'm going to show you why that is with this one, this example here. 5 times 5 times 5 is 5 to the 3rd, because 5 is used as a factor 3 times. And on the bottom, we simply get 5 times 5. We know that with fractions, if you have the same number top and bottom, that they simply cancel out, and we're left with just the 5. So what this looks like then is we take the 3 we had on top, we subtract the 2 we had on bottom, and we end up with simply a 5. For the next example, we have fewer on top than we have on bottom, so we end up with 11 minus 24 as our exponents, because we're going to take the 11 on top, take away the 24 on bottom. That's going to give us a negative 13. But we can't have negative exponents, so we're going to have to rewrite that as 1 over x to the positive 13. So basically 11 of these 24 canceled out, leaving 13 on the bottom. For the next example, we have a 7 and a 49, and I noticed that 7 squared is 49. So I'm going to rewrite that 49 as 7 squared. And I'm going to do this a little bit of a long way, and then I'll show you how I would do it the short way. So here I would take this and write it all on one line. This is going to be 7 to the 1 minus 2. This would be x to the 2 minus 3. And this one with the y on bottom means that he has a negative 1 exponent if I write him in this way. So this is going to simplify to be 7 to the negative 1, x to the negative 1, y to the negative 1. So that's going to give me 1 on top, a 7 on bottom, an x on bottom, and the y on bottom. So what I would normally do is say 7 goes into 7 one time, and it goes into 49 7 times. I have 2 x's on top, 3 on bottom. I'm going to have 1 left on the bottom, and the y just stays where it is. So the power law of exponents will be our next law that we look at. This is when we are raising a power to a power. In this case, that means that we're going to multiply. Well, why is it that we multiply? Because what this really says is 2 to the 2nd power times 2 to the 2nd power times 2 to the 2nd power. And if you're multiplying like bases, you add their exponents. 2 plus 2 plus 2 is 6. Or we could take a little shortcut and say 2 raised to the 2nd power 3 times is 2 to the 6th power. And 2 plus 2 plus 2 is 6. So it works whether you expand it and add, or whether you go ahead and use the law and multiply. Here we're going to take the shortcut and use the law and multiply. X to the 2nd power raised to the 6th power is x to the 2 times 6, which is x to the 12th. And here we have a product being raised to a power, and that means that each factor gets raised to this power. So we're going to have 3 raised to the 3rd power, and we're going to have x squared raised to the 3rd power. Now we apply our rules. Power raised to a power means we're going to multiply here, so this is going to give us 3 to the 3rd power, and our x is going to be to the 2 times 3. Simplify these, and we're going to get 3 to the 3rd power is 27. X to the 2 times 3 is going to give us x to the 6th. So we end up with 27x to the 6th. So these are the basic laws that you need to know for exponents, and now we just need to practice them.